Right, in today's video, we're going to be trying to do some ray tracing diagrams from a convex mirror with the type of reflection that happens with that type of mirror. So it's the same sort of ideas, but because with a convex mirror, the radius of curvature and the focal point are actually on the other side of the mirror, we actually have to kind of think a little bit differently about how we're going to draw all those rays. So a concave mirror is one that is kind of curved towards you. So if I'm faced this way, a concave mirror is going to curve this way towards me. I'm going to be looking as if I'm looking into a cave. If it's convex, it bends out towards me. So if you think about a spoon, and if you're holding the spoon so that the bowl of the spoon, like the side that you eat the soup out of, is facing towards you, that would be concave. If you're looking at the back of the spoon and looking at your reflection in the back of the spoon, that's more like a convex mirror. So the convex mirror is what we're looking at today, and we're going to go through example 12.3. It says that you've got an object placed 14 centimeters away from a convex spherical mirror. So here's my convex mirror. Here's my object out here, and it is 14 centimeters away from the mirror. Again, I've pre-measured this. Then it says that the radius of curvature of the mirror is 10 centimeters. So this point right here is where my radius is, and it's at 10 centimeters. That's the center of curvature. So the focal point is half of that. So my focal point is located right here at 5 centimeters. But again, you notice that it's on the other side of the mirror as opposed to being on the same side that the object is. So how are we going to draw these particular ray diagrams here? So let's start with maybe the easiest one, where we have a horizontal light ray coming in. So if I have a horizontal light ray coming in like this, what is supposed to happen with a horizontal light ray is it's supposed to reflect back through the focal point. Well, obviously it can't do that because it's got to come this way and the focal point's on this side. So I draw this ray as if it came from the focal point. So here's my point of entry, here's my focal point, and so I'm going to draw this light ray back this direction, okay, when it comes back off. Right? The second light ray that we usually draw is the one that goes through the focal point and then reflects back off parallel. Well, again, it can't go through the focal point, so I have to draw it so that it looks like it came from the focal point. So if I connect the top with the focal point like this, then the incoming light ray comes down like this as if it were traveling towards the focal point, and then it's going to reflect off parallel, that direction, okay? And then finally, we said that before I had a light ray that if it traveled through the center of curvature, it's going to reflect right back along that center of curvature. So again, since my center of curvature is back behind the mirror, I have to draw a line, and my ruler's almost not long enough. So I have to draw a line so that it comes through, or it looks like it's coming from the radius back behind the mirror, and it's going to come into the mirror, and it's going to reflect back right along the same line again. Okay, so just like in the second example that I did with the concave mirror, what you can see is that these reflected light rays are not going to intersect on the front side of the mirror. So once again, I have to extrapolate my light rays backwards. So if I extrapolate them backwards so that they go behind the mirror to see where they're going to meet, I'm going to extrapolate this one backwards here. I'm going to extrapolate my horizontal light beam. Well, I grabbed the wrong marker, so we'll extrapolate this one first. Extrapolate this one backwards like this. And then we will extrapolate the horizontal light beam backwards. And if everything goes well, they should be close to the same spot. I actually did a pretty good job that time compared to the last time I tried that. And so here you can see that all the 3 extrapolated light beams are going to meet right there. So I'll draw that with a dotted arrow to show that that's where my image is. So again, if I've extrapolated the light beams backwards, what that means is that I have a virtual image because the reflected light beams didn't cross anywhere. So I can't have a real image. I'm going to have a virtual image. It appears to be behind the mirror. You can see from the place where it crossed that the image is upright. So it's the same direction as the object is. And you can also see that it is much smaller than the original image. So this image is also reduced. So I have a virtual, upright, reduced image. So as you are working through some of these examples, you're going to be able to see rather quickly what kind of images are always formed by a convex mirror. So you're going to be practicing that today, and then you're going to be finishing filling out your chart on what kinds of images are formed based on where you locate the object in relation to the focal length for each one of these mirrors. Make sure that you check your answers to that chart with the answer key that I sent for that as well.